Hi, my name is Jackie Bondell. I'm the Senior Education and Outreach Manager for the ARC Center of Excellence for Dark Matter Particle Physics based in Melbourne, Australia. And this talk is called Bridging Scientists and Students with Regional School Partnerships. So just to give a little bit of background, so I work in this role as a senior education and outreach manager for this group, as well as a gravitational waves research collaborative. And my job is to take the contemporary research that's happening and connect that with students, teachers, and the general public. I also serve as the Australian representative to the International Particle Physics Outreach Group, as an EPO committee member for the LIGO-Virgo-CAGRA collaboration, as well as a NIAC for the IAU for Australia. And my email's there if you want to reach out to me about this project. It's jackie.bondell@unimelb.edu.au. And my background, I was academic, then I switched into education, spent a lot of time doing physics teaching and curriculum design. And now I get to work in a space where I get to bridge the science and the education. So just a little background and context. So I said this term, an ARC Center of Excellence. What it is, it's an Australian funding program where it's a multi-university research collaborative that has a funding from the government for 7 years to build easier pathways for collaborations by having researchers working in areas with a common theme driving ambitious science. So for the Dark Matter Center, as we call it for short, one of our major projects is the Southern Hemisphere's first underground physics lab, which is in rural, or what we call regional, Victoria. And it also includes some funding for outreach, communications, education, and EDI initiatives. So in the education and outreach portfolio, the main goals are to try to increase uptake and access to STEM opportunities for traditionally underserved groups. And we want to incorporate regional science connection in Stawell, Victoria, which is where our lab is. We want to develop programs and resources to support educators and to build the science communication capacity of our center members, especially our early career researchers. And today, I'm going to focus specifically on a project which is directed to increase this uptake and access to STEM opportunities in specifically our regional locations, as well as you can see how this program supports, also leads to providing support for educators. Now, you've probably seen this before. I enjoy this quote from the A Bridge Beyond the Point of Usefulness science book. And it says, Aristotle said a bunch of stuff that was wrong. Galileo and Newton fixed things up. Then Einstein broke everything again. Now we've basically got it all worked out except for pretty much everything. And I like to highlight this because if you look at the what's called the VCE physics study design. So that's just the state level Victorian curriculum authorities year 11 and 12 physics program, physics study guide. And one of the things that I think is relevant here is that, yes, we want to teach about how we do science, develop those skills. But I think one of the key things in the second paragraph is increase our understanding of the scientific processes, insights into how knowledge in physics has changed and continues to change in response to new evidence, discoveries, and thinking. And I think this is where dark matter science really plays a role. So I'm going to talk about something called the Dark Matter Partner Schools program. And for this program, the goal has been, since the start of the center, to create a program in which we can have a high impact long-term engagement with partner schools, where these partner schools are in regional locations. And we want this program to be relevant. We want to have a measurable impact, and we want it to be longitudinal in the fact that, instead of having one-off programs with many schools over the 7-year lifespan, what we're trying to do is to create, see if we can have an impact by focusing our energy on creating relationships with schools and students and see if that longer term engagement has an impact, and we specifically want to leverage partnerships. So we started this program in that same small town where our underground physics lab is at the bottom of the local gold mine. And in addition, we are creating content for teachers. We're trying to, once again, help our center scientists engage with students, and we want to measure the impact. So our dark matter school program, we've got 7 schools in very regional areas. We're currently on our 4th year with the first school that we piloted this with in Stawell, Victoria. We take a scaffolded approach so that what we do one year builds on what the students do the following year, with an emphasis on the nature of science. So not necessarily all dark matter content, but using dark matter as the lens through which we can understand the nature of science and the evolution of scientific understanding. Additionally, we are offering extended investigation projects for these students that they wouldn't otherwise have access to. And we're working with the University of Melbourne's Faculty of Education to look at the impact of the project. So next, I'm just going to focus on these 3 things in a little bit more detail. Now, the structure, like I said, is scaffolded. So obviously it's curriculum aligned, and we start with students in their first year of secondary school. Secondary school in Australia starts in year 7. So that would be equivalent to 7th grade in the US, where students are about 12 or 13 years old. And usually they will do common curriculum, covering very broad areas, year 7 through 9, some schools through year 10, and then for years 11 and 12, their last 2 years, they get to focus on a few specific areas. So in year 7, we start with this activity. How do we learn about things that we can't see? We talk about yes, we use dark matter as a lens, but really focusing on how we can learn about things that we can't see using traditional methods, and really getting into that scientific inquiry. In year 8, to align with their study of gravity, we talk a little bit about, and forces, we talk a little bit about how does gravity provide evidence for dark matter. So we talk about the solar system and how things move and how gravity impacts the motion of objects in a fairly qualitative manner. And then contrast that with what we see in galaxies to say, hey, this provides some evidence that there could be something that we don't quite understand yet. Year 9, we get a little bit more into how do we use light and how do we use that to map dark matter. Year 10, we start talking a little bit more about the structure of matter. So, atoms and how, what normal matter looks like, and contrast this to what dark matter may be. And then finally in physics, it opens up a little bit, and we're able to work with students discussing standard model, muons and special relativity, laws of gravitation, and all of those. So again, a strong focus on the nature of science and scientific inquiry with the context of dark matter. We also are providing extended investigation projects for our partner schools. So these are research opportunities for the upper level regional high school students to work with center scientists on year-long projects. We've done a strong push on the incorporation of muon detectors because that's been one of the areas of research for our scientists, focusing on the muon detection for our underground lab. And additionally, we're working on projects to collaborate with students in the US on high altitude muon study projects over multiple years. Last but not least, in the last minute here, I just want to talk a little bit about some of the early stuff from our collaboration by looking at the educational impact of this. So we wanted to look at what the impact might be by targeting these traditionally underserved schools. And with the university researchers from the Faculty of Education have done data collection through surveys, focus group, and interviews with teachers, students, and administrators. And the early data is showing that there seems to be a positive impact on the students' sense of belonging in science. And, that's an important indicator of whether they will uptake it in the future. And there also is sort of this unexpected thread of a pride and a sense of place in the locality of the experiment, and students really identifying with that science happening in their region. So this is about all I have time for. I will leave you with this final slide about one of our additional programs in which we travel around Australia, going to very remote schools as part of National Science Week initiative. Thank you.